Hi, welcome to Earthman Forge. My name is Mark Erdman, and I am a professional, full-time objects conservator, restorer. On this channel, I want to show you projects that I'm working on, such as this cast bronze statue, sculpture of a Native American. It's got some damaged pieces to the headdress here, where the bronze is broken off. It has quite a large crack and a deformed arm. So in this project, I'm going to use my TIG welder and restore those two broken pieces of the crown and the arm here. And then I'm going to do some surface cleaning. It's quite dusty, and some corrosion treatment. I have some active corrosion down here, which is this bright blue-green, as well as up here. The warm blue-green and brown color on the statue itself is actually an intentional patina. It's applied using heat and a chemical, in this case cupric nitrate, that achieves this color intentionally. But when we see this bright blue / white powdery substance here and here, I know that that is an active corrosion, and so I'm going to take steps to rectify that, in addition to the structural repairs that I'm going to make. So I hope you learned something and enjoy watching some of the steps of my process as I go about restoring this statue for a client of mine. Okay, so for the first step of the process here, I need to grind the break edge of the metal. This part I've already done a little bit of grinding on it just to see what it looked like, but in order for the welding process to be successful, I need freshly exposed bronze. So I'm gonna go ahead and use the die grinder while removing corrosion and creating a nice, basically I want to have kind of a V-shaped groove, so then I can fill the cracks on both sides with the fresh weld material. This is a little bit different process than I would take if this were a museum client. Museums are a little better suited to handle fragile objects. So I would probably use an adhesive repair for this at a museum, because I would know that prior to moving or lifting an object, the museum workers would consult the records, and they would know that certain areas on this sculpture have been treated in the past and that they need to be careful of that. But for a private client who's probably going to put this in their back seat, take it home, display it in their home, not everyone who encounters or interacts with the object is going to be aware that they can't, poke at it or bump it. One of the challenges to restoring broken components is the fixture, or the jig used to hold it in place while the adhesive is drying or while the welding is taking place. And so in this case, I'm using this. This is actually a apparatus stand used in chemistry labs, but it's really useful for holding artifacts. To join this broken piece, I'm going to be using my TIG welder. This is a Lincoln TIG 200 square wave. I'm using phosphor bronze rod and argon shielding gas. Got a tack weld on the front. I've laid it down so I can reach the back, get the welding in there, but I'm still using the clamp because if too much heat goes into that joint and it starts to melt the first weld that I did, the whole thing could fall off. So just waiting for the post flow to finish. That's the argon shielding gas that continues to flow afterwards to keep the joint from oxidizing. It's tempting to keep working it with the torch to get it to smooth out, but again, I don't want the whole thing to collapse. So I'm just taking it in short bursts of heat. I turned the amperage up to 110 from 100. It's still, I can see that there's a melted pool of filler rod, but it's not joined at the base of the crown. Another challenge with sculptures is that the thickness of the metal is not uniform. Welders are taught to use a certain amount of amperage for a certain thickness of metal. Bronze is very conductive, so the heat will go in, but the heat tends to travel, so you often need a higher amperage initially, and then you need to get in and get out so that you don't end up just heating the whole thing. But I am going to turn the amperage up just to try to get this to fuse at the base of that piece of the crown. It just does not want to melt. Could be that I've got wax in there that's preventing it from flowing, but I'm going to go in with a little mineral spirits to clean this area out, just in case any resins, waxes, lacquers could be inhibiting the flow of metal. It's pretty cruddy down in there, so that can prevent metal from flowing properly. Wax is soluble in mineral spirits, but I'm also going to use a bit of acetone to make sure I've got it nice and clean. I need to get that lump of weld material off of there so I can actually reach back in and fill in that crevice at the side. So back to die grinder, Christmas tree bit, safety glasses. Pull that electrode out a little bit. It's a little bit touchy because I don't want to hit the sides of the crown next to it while I'm welding, but I do want to be able to reach in there, down deep in that pocket, to get that to melt. It's solid, and as long as when I grind off the surface and chase out those horizontal lines, as long as it's still solid and I don't have air pockets, I'm good. Okay, I got that little fragment tacked in place. This is taking much less amperage than the crown did. So I'm going to turn it down. The foot pedal is adjustable, but just to avoid melting anything, I'm going to dial it back. Once these are all tacked together, that will also help avoid melting out the edges, because there'll be more mass in there and it'll all be connected together. It's delicate, but it's easier than this crown was. I got a little bead on one side, and I'm going to go to the other side, do the same thing, and then try to get it to join in the middle. Now I'll let that cool for a bit before coming back into it. Okay, next step, the back of the elbow here. Grind it out. Good morning. So what you just saw was my intern, Lauren, doing some grinding, both the angle grinder and the die grinder, to remove excess material, welded areas. You can probably see slightly different colors there. The yellow is the parent metal, which is a brass, and the orange is a phosphor bronze. Chosen because it's very effective at welding unknown metals and dirty metals. And I've got a little bit more to do in the crevice of the arm, and then of course up here on the crown. And then I'll do some sanding not heavy sanding because the surface is already pretty rough as it is, but just to remove the grinding marks, and then I'll do the patina. White powder is zinc that's boiling off and depositing on the surface. Nasty stuff to breathe in, that's why I have the fume exhaust. Still hot. Okay. But I got those little craters to fill in. Now I can just grind them down and I'll have a good surface. I'm not as concerned about creating a perfect finish on the inside here because all of these others have huge lumps and blobs all around. So I mainly want to just thin down the profile so that it looks correct from the outside. I like using this tool sometimes and just letting it chatter on the surface because it'll give a nice textured look that I don't know if you can see, but you have that textured look in other areas and the chatter of the tool recreates that nicely. Just kind of hold it loosely and let it bounce up and down a bit. Okay, I'm happy with that. Now I just need files to reestablish those horizontal lines across the weld. Triangle file. Or go ahead and repatinate it, clean the whole thing. So I've established the blue-green color using cupric nitrate. And now I just need to tone it down a little bit. Okay, well, that looks great. I'm happy with that. One big benefit of hot wax after washing is that it drives all the moisture off, and it enables the wax to stick a little bit better. Okay, so I've got a little corrosion spot there and there. I am going to use some mineral spirits to clean it, and then also some acetone, and then brush on some 3% benzotriazole in ethanol. And that is a treatment that we use. It will inhibit corrosion, and it'll darken the bright blue color. Known color values.